Technology channel. Myself, Divya Bharati, working as an assistant professor in the Department of Information Technology. Today, we are going to discuss about the topic conversion from NFA to DFA under the subject theory of computation. Let's we go to the topic. And two finite automata. Finite automata are abstract machines which are used to recognize patterns in input sequences and forming the basis for understanding regular languages in computer science. They consist of states, transitions, and input symbols, processing each symbol step by step. If the machine ends in an accepting state after processing the input, it is accepted or otherwise it is rejected. Finite automata come in two types, that is deterministic and non-deterministic, and it is also shortly known as DFA and NFA, of which can recognize the same set of regular languages. They are widely used in text processing, compilers, and network protocols. Deterministic finite automata, that is consists of five tuples q, input alphabet q, f, and transition, where q stands for set of all states and f in set of input symbols, and q stands for initial states and f stands for final set of states, and transition, that is transition function, which is defined by q cross input symbol, which is equal to set of all states. Here we have given an example to construct a DFA that accepts all strings ending with A. Here we have mentioned this with an itself loop. That is, all the DFA should be ended with A. So our final state would be ended with the A input. So here we have drawn the diagram for the given example, and here we are represented with the transition table. Here the transition of this each and every state has been denoted in this transition table, that is Q0 using the input A, it transits to Q1, and Q0 using the input B, it transits to itself loop, that is Q0 alone, and Q0 using the Q1 using the input A, it transits to Q1, and Q1 using B, it transits to Q0. The indication of arrow which indicates that this is the Q0 is the initial state, and the indication of double circle shows that the Q1 is the final state. Non-deterministic finite automata. NFA is similar to DFA but includes these following features. That is, it can transition to multiple states for the same input. Here, the Q not using the input A transits to Q naught as well as Q1. It allows null moves where the machine can change state without consuming any input. But in DFA, using the input A, there may be only one transition. Here, I have represented the transition of this given diagram in this transition table. Steps for converting NFA to DFA. Step number 1, convert the given NFA to its equivalent transition table. First, create the transition table for the given NFA diagram. So next, create the DFA start state. First, we have to denote the starting state for the DFA, and then we have to create the transition table with the help of the following states, and then create the DFA final state, simplify the DFA states, and repeat the steps 3 to 5 until no further simplification is possible. Here, I have given one example NFA diagram, and from this diagram we have to convert this into DFA by following these steps. Step number 1, transition function of NFA. We have to find the transition function for the given NFA diagram. So here I have mentioned the state, and here I have mentioned the inputs. So in this diagram they have given the input alphabet as A and B. So we have to find the transition of Q0 using A and Q0 using B, and Q1 using A there is a null value, and Q1 using B it transits to Q2, and Q2 using A it transits to null, and Q2 using B, and also there is null transition. In step 2, we have to create the DFA start state. So here we have to find the initial state of the start state, that is Q naught. So in NFA they have mentioned the start state as Q naught. So for Q naught we have to find the transition using A and transition using transition B. And Q naught using A we got the state as Q naught and Q1, and Q naught using B we got the state as Q naught. Here Q naught and Q1 we have to consider this as a new state, because in NFA there is more than one transition. It may be possible with the help of single input, but while we are converting it into DFA there is not a multiple transaction is not allowed. So we have to consider this as a single state and we have to consider this as a new state. So for this new state, we have to find the transition using the input alphabet, whichever given in the diagram. Our input alphabet is A comma B. So for that Q0 and Q1, we have to find the transition of Q0 Q1 using A and Q0 Q1 using B. So here we have find the transition, that is transition of Q0 Q1. We have considered this as a single state using the input A chances 2. So for finding this, we have to solve this as with the help of union operation, that is transition of q naught comma a union transition of q1 comma a. So for this q naught comma a, with this the previous NFA transition table, we may find that q naught q1 union, that is null value. So with this we have get the value of q naught and q1 state, so which is also old state, because we have considered this as a new state and we have finding the transition for the same q naught q1. So we are going to consider this as a new old state. And then q naught q1 using b, here we get using the union operation transition of q naught comma b and union transition of q1 comma b. So with this we may find that q naught union q2. So here we have to consider this as a single state, that is q naught q2, which is new state. So likewise we have to find the new state, and for that new state we have to find the transition using the A and B input alphabet. So it should be followed until we reaches the old state alone. So 3. So we have created the DFA's transition table, whichever we got in the previous transition. That is Q0, Q1 is new state, and for that we have find the transition. While finding the transition, we got another new state, that is Q0, Q2. For this also we have to find the transition with the help of the input alphabet A and B. So likewise we have to follow the same procedure, that is transition of Q0 comma A union transition of q2 comma a. So transition of q0 comma a, with the help of the NFA transition table, we find q0 q1 union, and q2 comma a we find the value as null value, and while giving the union operation we may get the value of q0 q1, which is also the old state, that is we have previously find the transition with the help of the input alphabets. So again we have to find the q0 q2 using b. Here we get transition of q0 comma b union transition of q2 comma b. So with this q2 q0 comma b, we get the value from the NFA transition table as q0 union. Here q2 comma b is null value, so there is a no transition. So finally while we are applying union operator, we get the q0, which is also old state that we have mentioned earlier. That is initial state of our NFA, which is also the initial state of our DFA transition table. So we didn't get the any new state. So with this we have to end up with the DFA transition table. Step number 4, create all the DFA's final state with the all the transition table. So here we have given that q0 q0 q1 q0 q2, which we have got as the new state. So and we have given the transition table which we got in the transition of DFA. So here we have to find the final state. So in NFA diagram they have mentioned the Q2 as a final state. So in this these states where the Q2 occurs, so that will be considered as the final state. In this transition, in this states only the Q2 will be occurred. So that is Q0 comma Q2. So we have to consider this Q0 Q2 combination as a final state. So we have to draw the diagram with the help of this DFA transition table. So Q0 q0 q1 q0 q2, we have given the name the states, and with this transition given in the transition table we have to draw the diagram. So q0 using a, it transits to q0 q1, so it transits to q0 q1, and q0 using b, it transits to q0 itself loop. q0 q1 using a, it transits to itself loop. q0 q1 using b, it transits to q0 q2. So here we have to mention with the double circle because this is a final state, and we have to given here as a arrow mark because q0 is a initial state. And then q0 q2 using a, it transits to q0 q1, and q0 q2 using b, it transits to q0. So we have find the DFA diagram. So we have to verify this whether it is a DFA or not. I already said that NFA has multiple transition for a single input, but DFA has only one transition for the single input. Here Q0 using A transits to single transition only. Here and also Q0 Q1 using B, there is a single transition for each and every states. With the help of a single input, there is a single transition. Then finally it will be considered as a DFA diagram. Likewise, we have converted the NFA diagram into DFA diagram.